Here's example 6 of using the law of sines. So another SSA case here, so two sides and one of the angles that's not in between them. So solve triangle ABC given angle A is 34 degrees, side A is 36, and side B is 20. We want to round to the nearest hundredth wherever appropriate, so that means 2 decimal places. So just like with the last several examples, we can't draw a picture yet because we don't have enough information to accurately get a picture, but we could just dive right in here. So we have capital A, and little b. So let's use the law of sines to find capital B. So we're going to say sine of B over little b equals sine of A over little a. And we're going to use that to find B. So sine of B equals B sine big A over little a. And we know little a and little b and capital A, so let's toss these into here, and we get sine of B equals, B is 20, A is 34 degrees, and little a is 36. Now, just like before, what we're going to do now is two different things. We're going to get B is the inverse sine of this, or 180 degrees minus the inverse sine of that. We explained that in example 5. We explained why we do that. And since it takes a little time, we don't want to go through it again here. But if you want to see the explanation of why we do that, check out example 5 in the previous video. But anyway, before we do that, we have to make sure that 20 times the sine of 34 degrees, make sure that we're in the degree mode, DEG for deg degree, divided by 36. So that's about 0.3107-ish, so that is something that we can take the inverse sine of because it's between -1 and 1. Okay, it's between -1 and 1, so we can take the inverse sine of it. It's totally legitimate, it's okay, it will work. That's great. So now, now we say B equals the inverse sine of 20 sine 34 degrees over 36. Yes, we could simplify and reduce that, but we're going to shove it all into a calculator anyway, so there's no point. So we have this, or, just like in the previous example, or B equals 180 degrees minus this mess right here, minus the inverse sine of 20 sine 34 degrees over 36. And again, we explained why we do this in example 5, so check out the previous video if you want to know why we do that, why we do B is this or this. So that's the trouble with the ambiguous case, though. The SSA case is it could lead to this ambiguous case where you might have these two separate things here. So just more work hidden behind the scenes. Okay, now we just toss this into a calculator. So let's see what we get. Now be very careful, we don't want to use this approximation or any rounded value that, we just want to toss this exact value into there. So we take the inverse sine of this, or we do 180 minus that, making sure, whoops, I guess we need to get the approximation actually, so approximately equals, okay, or 180 minus that, and making sure that we're in degrees the whole time. So the inverse sine just gives us 18.0992 if we round out to 4 decimal places. Okay. Why 4? So the directions say round to the nearest hundredth, but let's round it out to 4 for now, in case we have to use this approximation later to get another value. So B is approximately 18.0992 degrees. Okay. Or from the separate case, B is approximately what? Let's check that. 161.9008-ish. 161.9008 degrees. Okay. And again, we're rounding out to 4 decimals in case we have to use these approximations to get other values later. And we always say avoid using approximations if you can, but if you can't avoid them, if you absolutely have to use an approximation to get another value later, then round out to more decimals than you need. Okay, we only need to round to the nearest hundredth, but let's round out to more so that when we use these approximations to get other values later, that will help us minimize the round-off error that we get. Okay, so now that we have B and A, now we have two separate cases going on. So let's get C. So A plus B plus C equals 180 degrees. A is 34 degrees. B is 18.0992-ish degrees. C is unknown. 180 degrees is 180 degrees. Okay, so when so 34 degrees plus this mess here plus C equals 180 degrees. So it's just a simple linear equation. When we solve for C, we get C is approximately equal to, and we say approximately because this is an approximation. We get C is approximately equal to 127.9008 degrees. Okay. And again, we're still going to keep this out to 4 decimals because we might have to use this C to get something else later. Okay, so that's this. Now let's, what do we need? So we have big B, we have big C. All that's left really is little c. So let's use the law of sines to get little c. So little c over sine of big C equals, let's use little a and capital A, because we're given little b, but capital B is an approximation, so we don't want to use it if we don't have to. So let's avoid using that. So we'll just use little a over sine of capital A. Okay, so this tells us that little c equals little a over sine of big A times sine of big C. Okay, multiply both sides by sine of big C to get this. And then that equals little a is 36. Big A is 34 degrees, so this is sine of 34 degrees down here. And then we're multiplying by the sine of C, big C, which here is 127.9008 degrees. 127.9008 degrees. Okay, so that's why we kept it out to 4 decimals, because now we have to use this approximation to get another value, and we don't like doing that. So if we have to use an approximation, let's round it out to more decimals than we need. Okay. So anyway, this tells us that C, little c, is approximately what? Well, let's toss it all into a calculator and see what we get. So when we toss it into a calculator, making sure we're still in degree mode, so what do we get? We're going to have 36 divided by the sine of 34 degrees times the sine of 127.9008 degrees, and that's approximately equal to 50.79949. But we only, since we're pretty much done now with that case, we only have to round out to 2 decimals. So let's say 50.80. Okay, 50.80. Okay, so C is about 50.80. Okay, so that's it for that case. So let's summarize the answers there. So we'll erase this mess here, because we don't really need that anymore. So now for the final answer, we only have to round to the nearest hundredth. So let's say big B is approximately 18.10 degrees. Okay, if we round to the nearest hundredth, that's going to be 18.10. Big C is approximately 127.90 degrees. And then little c we got was approximately 50.80. Pretty big. Okay. Okay, so that's for that case. Now let's check this case over here. So we have to go through all that stuff again, maybe, and see what happens there. So start by getting the other angle. So we have big B and we have A. So A plus B plus C equals 180 degrees. A we were given as 34 degrees. B is this mess right here, 161.9008 degrees. Plus C equals 180 degrees. Okay, so if we continue with this, erase that, make some room. We continue with this, what happens? Well, we could just kind of eyeball this and stop and say it's actually not going to work out. Why not? Well, what happens if we solve for C? So if that doesn't jump out at us right away, we can still solve for C, and we'll get C is approximately what? So C is going to be 180 degrees minus 34 degrees minus 161.9008. So if we do that, so we're just solving this equation for C. So if we zoom in on that, what are we going to get? 180 minus 34 minus 161.9008. Negative 15.9008. So that's a problem. Why is that a problem? Well, it's a problem because it's a negative number. So C is approximately negative 15.9008 degrees. And that's, no, that's just not going to happen. Triangle cannot have a negative angle like that. So since C is negative, this actually gives us no triangle here. So no triangle. So even though we have the ambiguous case, this second case over here does not give us any triangle. So that's something else that could happen with this SSA. So that's example 6. The only possible triangle we could have is here. And if we were to try and draw a picture of that, we see that, so angle C is the obtuse angle. So this is really horribly not to scale, but and also pretty poorly drawn, very poorly drawn. But here's angle C, here's side little c across from that, and angle A would be, I guess, this one, and then angle B would be this one over here, I suppose. So side little b, side little a. So the triangle would look something like that, kind of, sort of, not really to scale, but anyway, here's the obtuse angle, angle C. And again, even though we had the ambiguous case, this one doesn't work out, so we only have the one triangle. So that pretty much, this example is the last one that covers all the cases that the SSA case could give us. So remember, in the beginning, we were given angle A, and side B. So we were given angle A, and side B. So that's side angles. We were given the SSA case. So when you have the SSA case, you could have no triangle, which we saw in example 3. You could have one right triangle, which we saw in example 4. Or you could have one just more general triangle. It could be acute or obtuse, and that's what we just saw here. And at example 5, we saw the case where you could have two triangles. So SSA leads to the ambiguous case where you could have one or two triangles. And this is example 6 of using the law of sines.